Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster game in C++ series, and in this video we are going to add better editing functionality to our engine by adding support for multiple textures. So before we begin doing anything with the actual editor interface, we are first going to have to set up the foundation for having multiple textures. So as you already know, we store our maps as integers, and since integers can be any value, we are currently only storing them as 0 or 1, but we can store values greater than 1 to represent different textures. So for this we are going to have to of course modify our render code a bit as well, but first of all let me show you the end result of our efforts in this video. So let me just run make here, and you can see we get this Raycaster which has got this kind of tiling here, and if I go ahead you can see we've got these blocks which are different tiling, and I can go ahead and open up the editor by pressing escape. And now you can see that the editor shows this editing options window in which it shows a preview of the current selected texture, and I can change the texture that I want and I can use that to draw. So I can change this, for example, to this, and I can change the left one to this, and if I go here you can see that we are getting a different texture on each of these. And if I go in here, I can change this whole area to be a different tile. For example, this one, I can go ahead and do it like that, and it should basically cover the whole place with the blue tiles. So I can go ahead and paint it like that. And if I go under my 3D view, you can see that this wall is made with the red tiles, but this one is made with the blue tiles. And I can go ahead and change this one as well. And yeah, you can see that it basically works. And of course, I can save my progress here. So yeah, that means that our editing functionality is working pretty awesome. So as you can see, we are showing a preview of the texture inside of this here, so inside of our editor. So we are going to have to access the editor, the texture from multiple places, from the editor and from also our render code. And because we of course don't want to reload the texture for each of those, we just want to keep a single resource in the game that is going to basically store the whole texture for access by anything. So we are gonna create a new class. So I have already done that. Let me go ahead and open up resources.h here, and also resources.cpp. So this is basically going to be a class that will store our different textures, and it will just contain a bunch of static public variables that we can just use to kind of have global variables that can be accessed from anywhere. So you can see we have got SFML graphics textures.hpp here, and we are including that header because we are creating a texture called wall texture. And in resources.cpp we do really nothing, we just define this wall texture because static variables need to be defined in an implementation file. So we define it here, and and that's pretty much it for our resources file. So I'm going to now, if I go here, this is the only new file we added, but we are going to go ahead and open up our, let's open up our renderer now. So if I open up render.h and render.cpp, you can see that inside of render.h we currently, I'm going to go full screen, and you can see inside of render.h we have got a SF texture. We have got an SF texture for our sky and floor because we still use the same mechanism for that, but our wall texture does not exist inside of the renderer because we use the one from the resources. And in the init function we do not really load our wall texture here anymore because that's going to be handled globally by the main file. Speaking of that, let me open up main.cpp, and inside of this you can see that we basically go ahead and just load the resources wall texture. So we just load it from the wall textures.png file, and you can see that this png file is now called wall textures and not wall texture. Why is that a distinction? Because now we store all of our textures in a single file, in a single row basically. So where each column represents a single texture. So if I go down here, let me just move down here, you can see that we are using a render states to render our texture. Let me just go to the end. So you can see we are doing this, and of course now we are, wherever we were using wall texture earlier, we are now using resources wall texture. And ignore this code for now, we will get into this in a second. But first of all, what you need to understand is that when we do this, we can't actually render a single vertex array with different textures. We can't apply different textures to a single vertex array, and having different textures for each of the wall textures will kind of make it complicated as well. So the easiest way to fix this without causing any complications is to basically just go ahead and you know store all the textures in a single file and use different texture coordinates to access them, which brings us to our new renderer code. So if I go here, the only thing we have changed here is that now instead of creating a boolean called did hit, we are creating an integer called hit. And down here where we were testing our map, is we just do the bounce check and then we set our hit to that value. We don't actually change it or anything. So we are going to set that to that value, and we are going to continue until our hit is, while our hit is 0. So now let me go down here. You can see if the hit is greater than 0, then all we do is that we go ahead and calculate everything like we were doing earlier. And now of course for calculating texture size, we use resources wall texture instead of the wall texture member variable. And the main difference is that now when we are assigning our the actual texture coordinates, we use of course our texture variable, but we add to this our hit minus 1 multiplied by the texture size. So why do we do that? The reason is that, well, the y value of the texture's actual size represents the size of each individual texture. So we take that and then we take the amount that we hit, and of course we subtract 1 from the hit amount because we want to be able to use texture at index 0. So if for example we hit at 1, then that would give us index 0. We will multiply that by the texture size, which will give us 0, which means we'll access the first texture. However, if it's not actually 0 but 1, instead it's 2 for example, then we'll get 1 here and we'll add texture size to our texture x, and that will move us to the second texture. So this is the basically way we are gonna draw different textures quite easily. And of course we do the same thing for the second point of the wall as well. And yeah, that pretty much works for our renderer. Now I'm going to close down the renderer, and let's go ahead and focus on our editor's code now. So let me open up editor.h. There's only one thing that I've changed here, which is that we have got a new private variable called texture number. This is going to represent the actual texture that we are drawing with currently. So let me open up editor.cvp to see the implementation of this. So if I go down here, you can see that we have got our menu pretty much the same way as before, but now we have got a new imgui command here, which is imgui begin. So this begin in imgui begin will basically create a new window, and I said that you need to only call n main menu bar and n menu if the functions return true. However, in the case of begin, it's different. When you are creating a window, you need to call and regardless of whether begin returns true or false. So we are going to not do any if statement in here. Alright, so in between this we can put anything we want to be visible inside of the window. So the way we do that is by, first of all, we have got a text. As you can see, this will just display a static text, which will basically be a label, and this will be texture number, and we'll just put that on the first line of our window. And then we'll say imgui same line. Now this function will tell imgui to put the next item, whether we put anything, we are putting this input integer here, so the next widget that we put, it will instruct imgui to put it on the same line. By default, imgui will just move everything onto the next line, but we want the texture number control to be displayed on the same line, so we'll do it like this. And actually you can remove that if you want it to be displayed on a separate line. I'm actually going to remove that. So you can see we have got an imgui input int here. Now this will allow us to create an input basically slider, or allow the user to kind of change an integer value, and of course we'll need to pass a pointer to our texture number, and this will allow our user to modify the actual texture number that we have got inside of our editor. And you can see that we have got this hashtag texture number here. The reason is that this is the actual label of the text, of the texture of the input field actually, and this needs to be unique for every input field, or else you will get weird errors. So in order to make sure, because we don't want to actually display a label underneath or towards the right of the texture of the input field, we don't want to actually display a label, so we use this hashtag, and two hashtags means that imgui will not display any text after this. And since the only text we have is after the hashtag, then that means no label will get displayed, and we'll get our input field, just the input field and nothing else. So that gets that out of the way. And now here you can see that the next thing we are doing is actually constructing a preview. Now what this means is that of course the user will we want the user to be able to see what the user is drawing. So the texture that's selected, we want that to be visible. So for that, first of all, we get our texture size and an integer from our resources wall textures, and of course we use y here since that's the actual texture size for an individual texture. And then we put a text here for telling the user that this is the preview. and then we use imgui image. Now this imgui image by default has a bunch of different overloads. Generally it just has one overload in imgui, but if you include imgui sfml.h, it has got another overload here that's designed to work specifically with SFML textures and sprites. Now we don't put the texture here directly because we only want to draw a small portion of the texture, the individual texture that's selected versus the whole map. So in order to make sure we do that, we use an SF sprite. We initialize the sprite with the wall texture, and then we go ahead and pass it an integer rect, which is basically going to represent the actual amount of the texture that we are displaying. And it's for the width and height, of course it's just texture size and texture size, but for the top value is 0, but for the left value we are basically taking our texture number and multiplying it by the texture size. So we are basically accessing the that in a similar manner like we were accessing it in the renderer. And the second argument represents the actual window size of the image that we displayed on, and we just set it to 100. You can set it to whatever value you like. And once you are done drawing everything on a window, you must call imgui end, or else it will not work. So if I go ahead and run make now, that's pretty much all the changes. And if I run make right now, you can see that we get this raycaster, and I can move around, and you can see that the changes we made earlier are now preserved. And I can go here, I can go ahead and of course I can resize this window as well. So I'm going to resize it to something like this, and I can increase the texture number, and you can see it's displaying a dynamic preview of the texture that will be drawn. So I can go here, I can go ahead and edit stuff like this. So yeah, that's pretty awesome. We can edit things like we want to, so we can just add different kinds of stuff here, and of course we can save our map as well. So with that, we have got this basic stuff working, and of course currently we have got this only implemented for the wall textures, and you could do something similar with the floor textures and maybe the ceiling textures as well. But for that you will need to create a multi-layer map and multi-layer map editor with one layer representing the floor and one layer representing the walls and one layer representing the ceiling. But we'll maybe look into that in some other video. For now, it is pretty much it for this video. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people. And